today we're going to talk about special products. But first, let's remember FOIL. So I'm going to give you a practice FOIL problem. Alrighty. So, special products. This is going to involve a lot of FOIL, which is why I had you practice it. The first thing we're going to talk about is squares of sums. So this is written like some kind of A plus some number B, and that whole quantity is squared. Remember, I have to write out each factor. So I'm going to have A plus B quantity times the quantity A plus B. This is not in any way equal to A squared plus B squared. No, this is bad. Okay? Why? Because when I went to FOIL this, I would have A squared plus AB plus another AB plus B squared. Okay? And I would combine like terms, and I would have A squared plus 2AB plus B squared. This does not look like this. So do not use that. If you see a sum of squares written like this, it will always follow this rule. Okay, so I can jump straight down there. Let's go ahead and practice this. So let's say I have x plus 4 quantity squared. So I know that I square the first, that A term, A squared, and then I have 2 times the A times the B, so 4x was A times B, so 2 times that, plus my B squared, which is 16. So I would have x squared plus 8x plus 16. And I can check it by doing all-out FOIL if I really want to. So my first terms would give me x squared plus 4x plus 4x plus 16. Which simplifies to x squared plus 8x plus 16. So the special product you'll learn is really just a neat way to do it without doing as much work, because I can jump from here straight down to here with some help from mental math. So go ahead and try this next example on your own. So in addition to squares of sums, I can also have squares of differences. And what I mean by squares of differences is instead of A plus B inside my parentheses, I have A minus B squared. Again, when I write that out, it's A minus B times A minus B. In no way is that equal to A squared minus B squared. It's not. Remember, if I FOIL it, I'll get A squared minus AB minus another AB plus B squared, which simplifies to A squared minus 2AB plus B squared. So the only thing that changes from squares of sums to squares of differences, instead of a plus 2a, now I have a minus 2a. And again, should I want to take this shortcut, I can jump from here down to here easily. Try this example on your own. We'll take 6p minus 1 quantity squared. Try that on your own. If I square the first term, I should get 36p squared. Twice the middle term would be minus 6p. Twice that is minus 12p. Plus 1 squared is just 1. So that would be my answer. The last thing we're going to talk about with special products is the product of a sum and a difference. Which means I'm looking for example, an A plus a B and that same A minus a B multiplied together. This when I FOIL it, is going to have a squared. Outer would be minus ab. My inner would be plus ab. My outer would be minus b squared. If you'll notice, I can combine like terms, and a minus ab and a plus ab will cancel out and give me 0 ab. So that my final thing would be a squared minus b squared. Let's do an example of this together. Let's say I have 3x plus 2 times 3x minus 2. Well, I see that I have a product of sum and a difference, so I know I can jump down to here. So I'm going to square my first terms. 3x times 3x would give me 9x squared, minus my last terms, 2 times 2 would be 4, and my middle terms have dropped out completely. Again, if I check this by FOIL, I would have gotten 9x squared minus 6x plus 6x minus 4. These cancel out completely, and I get that 9x squared minus 4. Try this last example on your own.